This is lesson 2.2, adding real numbers. You should be on page 74. This first paragraph just gives a quick summary of what you can do to add two numbers using a number line. I'm going to quickly go through this. This is something that I perceive you would have been taught probably starting as early as 5th grade, maybe earlier, and you've reviewed this for sure up through 8th grade. When you add numbers, and you could use a number line to add numbers, they're demonstrating that here. When you add a positive number, it's basically just moving numbers to the right. And if you add a negative number, that means move on a number line to the left. Here would be a couple simple examples. Look at -3 plus 6. If you start at -3 and then you move 6 units to the right, you end at 3. That means the answer to this problem would be +3. Or here would be a second example. -4 plus -5. I'm going to start at -4. I'm going to go 5 units to the left because I'm adding a negative this time, and I finish right here, and that finishes at -9. The answer to this would be -9. Now, you could do every single addition problem with positive and negative numbers in the way I just showed you right here. The only problem is that kind of becomes inconvenient after a while, drawing number lines and so on. Here are the directions. Use a number line to find the sum. Well, let's just do a few more with the number line. Just in case you're not sure, make sure that you see what I'm talking about. 7 plus -2, I can get the answer right. I could start at 7, which is here. I can add -2, which would go this way, and I end up at 5. The answer to this is 5. Or 8 plus -11. I could start at 8, which I'll draw here. I could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 left, because I'm adding -11, and my answer would be -3, and you can see that here. Or one more, -8 plus 4. I could start at -8, and I could add +4, which means go 1, 2, 3, 4 to the right, and you can see my answer to this would be -4. You can do every single problem that way, but I will be honest with you, that becomes a pain in the rear end after a while, drawing number lines and having to move left and right. And what happens if I give you problems with decimals like -15.1 plus 24.7? All of a sudden, the number line thing can get old real fast and become a headache. We don't want to have to do all our problems in this way, even though this is a good visual. That's why you'll see in the key concept box on the next page, there's a couple of important rules that if you learn these rules, you can add positive and negative numbers without having to draw the number lines. The first of the rules is right here. To add two numbers with the same sign, you are going to add their absolute values. Let me highlight that real quick. You're going to add their absolute values. The sum has the same sign as the numbers added. Now, if you're reading that and you're like, what in the heck is that telling me? Well, here would be a simple way of saying it. I'm going to speak here not as a math teacher. I'm not going to speak math teacher speak. Let's do this one because this problem is this description. I'm adding two numbers with the same sign. Here's what this verbiage that I'm underlining is telling you to do when you're adding numbers with the same sign. Forget about the signs for a minute. Treat this like you have 1 and 4. Add 1 and 4. You get 5. Since the numbers in the problem were negative, that means the answer has to be negative. So the answer to this problem would be -5. That's what this is telling you. If the signs are the same, forget about the signs for a minute, add the numbers up, and put the sign in your answer of what signs of the problem had to start. You know, here'd be another example, 7 plus 8. Okay, forget about the signs for a minute. 7 plus 8 is 15. Okay, now, since the numbers were positive, I know my answer is positive. I'd get 15. So if I'm adding up two negative numbers, just forget about the signs, add the numbers up and put a negative in front, And if I'm adding two positives, just do what you've done your entire life. Add them up, and there's your answer. Now, the second rule, what happens if we add numbers with different signs? It says to subtract the lesser absolute value from the greater absolute value. The sum has the same sign as the number with the greater absolute value. Now, if you're like, what exactly is that telling me? Let me say it in non-math teacher speak. Let's go to this example up here. Now, we already worked this out on the video. Using number lines, we knew the answer is 5. I'm going to use this rule and show you how you get the same answer without the number line. Do you see how I have different signs? This, what I'm underlining right here, is telling you, forget about the signs for a minute. Just treat the problem like it's 7 and 2 and subtract. You get 5. Now, look at 7 and 2. 7 was positive, 2 was negative. Do you see how 7's the bigger number? Since 7 was bigger than 2 and 7's a positive amount, that means the answer should be a positive amount. The answer would be positive 5, just like I said earlier. Okay? Here's another one. Now, you know the answer to this problem from prior in the video was negative 3. I'm going to use this rule right now, and we're going to work out this problem using the rule. So, I see a positive and negative number, and I'm adding. This rule says forget about the signs and subtract. So let's forget about the signs and subtract. 11 minus 8 would give me a 3. Okay, now let's think about 11 and 8. Which one is bigger? Well, obviously 11's bigger. Okay, what sign did 11 have? Well, 11 had a negative sign. That means your answer should be a negative answer. The answer is negative 3, which is matching what I said earlier. So those two rules are important. If you're adding with the same sign, just forget about the signs, add up the numbers, and use the sign of the numbers in the problem at the end. And if the signs are different when you add, forget about the signs, quickly subtract, and use the sign of the bigger number in your problem with your final answer. When we practice these things, we are not going to be using a calculator. So when you do the homework, make sure that the problems I've identified in Plan Book that I said no calculator, make sure you're actually practicing that way, because on quiz and test day, I'm not letting you use a calculator for those. There are some properties of addition that we must know, and I'm going to put a bunch of stars by this. This is super important. These 4 properties I'm going to walk through. Make sure you clearly write these in your notes, and make sure you clearly put examples of what these properties are telling you, because on quiz and test day, yes, you need to know the name of the property, and yes, you need to be able to identify what property is each situation. These are all properties of addition. Maybe I should circle this. All 4 of these are properties of addition. The first property I'm going to talk about is the commutative property. It says the order in which you add 2 numbers does not change the sum. So in other words, you notice here, they have on the left side of this, on this example, the left side of the equal sign, 3 plus negative 2, and on the right side they change the order. The commutative property says you can change the order when you add and you're going to get the same answer. Let's think about it. 3 plus negative 2, by using the rule I just learned, well, I can quickly, I got different signs, I'll quickly subtract. I get 1, and since 3 was bigger and it's positive, this would be 1 over here. And you notice if I do negative 2 plus 3, I'm going to get the same answer. You notice when I change the order of adding, I get the same answer. That's called the commutative property. I can change the order when I add and get the same answer. The second property is the associative property. Now, do you notice it says the way you group, it says 3 numbers here. It's really 3 or more numbers. It doesn't have to be 3. It could be 5 numbers. It could be 10. Okay? The way you group 3 numbers in a sum does not change the sum. In other words, you can group differently and you should get the same answer. Let's see that in this example. You notice the order didn't change. Negative 3 was first, 2 was second, 1 third, and over here, negative 3 first, 2 second, 1 third. The order didn't change. Here's what did change. Look at the parentheses. On the left side of the problem, they're telling you to group negative 3 and 2 first, but on the right side, they're grouping differently. Let's see if we get the same answer. Negative 3 plus 2 is negative 1. And then if you add 1, which is what's here, this works out to 0. Let's go on the other side. Let's do 2 plus 1 first. That would be 3. Is negative 3 plus 3 going to give you 0 also? Yes, it does. So if I group differently, I still get the same answer. That's the associative property. The next property is called the identity property. The sum of a number and 0 is the number. In other words, if I take a number like negative 5 and I add 0, I get negative 5 as the answer. I keep the identity of the number I started with. That's why they call this property the identity property. If you take a number and you add 0, you get the same number you started with. You kept the identity of the number, okay? So that's why that property is called identity property. Whenever you add 0 to a number, you get the same number you started with. Finally, the fourth property of the group is the inverse property, okay? The inverse property, just going to get that arrow out of there. The inverse property says the sum of a number and its opposite is 0. Now, opposite is a term that is from lesson 2.1. Remember, numbers that are opposites, one would be positive, one would be negative. They're both the same distance from 0, okay? This is saying if I add a number and its opposite, I should get 0. For example, negative 6 plus its opposite, which would be positive 6, adds up to 0. That's called the inverse property. Whenever I add opposites, I should get 0. Like here would be another example. Negative 10 plus positive 10 would give me 0. This statement would be an example of the inverse property, okay? There are two other vocabulary words that we should know that associate with these last two properties, okay? Additive identity, it says the number 0 is the additive identity. What that means, if I take a number, I'll pick a number, a 9. If I add 0 to it, I keep the identity of the number I started with. That's why the number 0 is called the additive identity. In other words, it's the number I can add which doesn't change what I started with. It keeps the identity. So the number 0 is called the additive identity. I would definitely get additive identity in my notes and make sure I'm clear that understanding that this term, additive identity, means the number 0. The second term is additive inverse. It says the inverse property, which we had here, states that the sum of a number A and its opposite is 0. The opposite of A is the additive inverse. So additive inverse is kind of another way of saying the word opposite, which you see here. So if I take 23, if I add the additive inverse of 23, which is negative 23, I would get 0. So additive inverse and opposite are similar terms. They're telling me the same thing, okay? The opposite of 23 would be negative 23, but that's also called an additive inverse. So those are two things we definitely want to have in our notes. They walk through a quick word problem using addition. I'm going to skip that on the video. This is something you can review on your own. It's pretty clear what they're doing. They're taking manufacturer A profits, adding them up, manufacturer B profits, adding them up, and seeing which one is a greater profit. I want you to pause the video real quick and try 5 through 10 on your own, and they'll take a minute or two, and then let the video run and we'll walk through them. Okay, we're back. Find the sum. Well, you see how the signs are the same. So that means forget about the signs for a minute. Just add the two numbers up. That would be 6 and 3 is 13, carry the 1. This would be 7.3. Don't forget to line up your decimals. And since the numbers were negative, my answer should be a negative 7.3. Okay? Here, you notice how the signs are different. So let's just forget about the sign. 16.2 minus 10.1. Remember, when the signs are different, we're subtracting. That would give me 6.1. And now let's look at the numbers. 10.1 and 16.2. That's bigger, and it was negative. So put a negative in front. There's my answer, negative 6.1. Okay? 7, same thing. I have different signs. So forget about the signs and subtract. Whenever we have different signs in an addition problem, you just forget about the signs and subtract. Good borrowing practice here. I got to borrow from 1. I got to carry 10 over, which would make this 13, but wait, I got to borrow again, so I'll make this 12, and I'll carry 10 over, which makes that 11. So 11 minus 7 is 4. 12 minus 8 is 4. So 4.4. Now, before I'm done, okay, 13.1 is bigger than 8.7, and 13.1 was negative, so don't forget to put a negative in front, negative 4.4. What property is being illustrated? Okay, so when you look here, I'm adding opposites together. I'm adding opposites together. So when I look back at my list, and again, we want to remember the names for these. Is it clear? I just want to make sure. Is it clear why that's the inverse property? Okay, I'm adding inverses together. I'm adding additive inverses together. This is the inverse property of addition. Okay, here, this is the additive identity property. I'm taking negative 12, I'm adding 0, and I'm keeping the identity of the number. This is the identity property of addition here. And the last one is definitely the commutative property. Do you notice how I'm changing the order of adding? The commutative property allows me to change the order of adding. That's the end of the video. If you have questions, bring them to class tomorrow.